Hello and welcome to our second session about the power of the cell. I would like to remind you all first to have a look on our previous video about the rules of this channel and the first two sessions about power of the cell, the introduction and power of the cell 1, where we explained the general structure of the cell. Hello and welcome to and second session. We agreed that about the power in this session, I would like to remind you all first to have a look on our previous video about the rules of this channel. And in this session, our main target is to explain why we recommend cells and we commend cell therapy for our patient in the regenerative medicine clinic, and why I'm calling to generalize the prescription of cell therapy and the different applications of cell therapy to be included in the normal prescription, the regular prescriptions of doctors. We will understand this step by step after we get exposure to each component of the cell. What can it do? What it cannot do? How it can participate in the clinical management of different cases. As we see in front of us, and as we discussed in the previous video, the general structure of the cell is the cell membrane, the cytoplasm, the cell organelles, and the cell nucleus. So when we talk about cell, there is nothing, there is no organ we can catch it, we call it cell. Cell is different components: cell membrane, cytoplasm, organelles, and the nucleus. These are the main components of what we call cell. Each component of these of the cell play a very important role in its function, its survival, its multiplication, and how it can perform its function within the organ, the assigned organ, within the body. So the importance of each organelle here is extremely important. Let us remember that we have only two main functions for our body. Our body has two main functions. The function number one is survival. The job of each organ in our body, each cell in our body, its first function is to survive. The second function is to multiply. So, when we talk about any organ, when we talk about any cell, we will talk about these two main functions first. Number one, how this cell can survive. Number two, how it can multiply. Survival for each live organism comes by two very important processes. Number one, ingestion of the needed material to keep it alive. Number two, respiration. And this is why our lecture today will be about the mitochondria. Before we go to the mitochondria, I want to remind myself first and the audiences second to the meaning of the word essential, because there is a different meaning in medicine than English for the word essential. Essential in English means absolutely necessary or extremely important. If we apply this to the different elements in life to our body, all of them are essential. Because any small element can make us lose our life. Sodium, potassium, magnesium, the imbalance of one of these elements can make us lose our life or a severe dysfunction in our body. So essential in English means absolute necessary, and if we apply this meaning, so everything is essential for us. But in medicine, the word essential is different. Essential in medicine means it's a material the body cannot synthesize it on its own. Material The body cannot synthesize it on its own. Let us think about example for this. Uh, the insulin, for example, which is a polypeptide, 6 amino acids polypeptide chain. All of us know what is the importance of insulin for survival and for the metabolism of sugar in our body. This this 6 amino acid polypeptide chain, if it's absent, as what happens in diabetes mellitus, the body cannot synthesize it on its own and need to be supplied from external source. And because of its nature as a peptide, it cannot be ingested by mouth. Otherwise, it will be digested in the stomach and cut into basic amino acids. So it should be supplied to our body in a parenteral way to avoid the digestion in the stomach. So this is a very obvious and very famous example for the word essential. A material the body cannot synthesize. Let's talk about glucose. Is glucose essential or no? From the English meaning, it is essential. However, if I do not eat some carbohydrates or some material contain glucose, the body can transfer some amino acids and transfer some fat cells in my body into glucose in a process we call it gluconeogenesis. So, from the medical point of view, glucose is not essential. But as it is absolutely necessary or important, extremely important or not, it is important. This is why the body synthesizes it inside it. However, from the medical point of view, it is not essential. So, essential in medicine means it's a material the body cannot synthesize it on its own. From this point, we divide the amino acids into two different types: essential amino acids and non-essential amino acids. Both of them are important, extremely important. However, the essential amino acids, the body cannot synthesize it on its own, so that it should be present in the daily dietary regime of the human being. Let's move one step forward to go to our subject today, which is the mitochondria. If you ask anyone about mitochondria, he will say to you, it is the powerhouse of the body. This is what everybody knows about mitochondria. It is a powerhouse of the body. Yes, this is true. And mitochondria is the cause for which, if we remember the last session when we were talking about the power of the cell and how it gives energy to the sperm to be able to cut the very long distance from the cervix to the ovum, the source of the energy is the mitochondria. The mitochondria which is gained from the father. And this maybe drag us to some interesting point, is which most of you know it, or somebody maybe don't know it. The mitochondria in our body today, its source is from our mothers, not our fathers. Because the mitochondria from the father was already exhausted by the sperm to be able to reach the ovum. And the head only can enter the ovum, so that the neck and tail are discarded outside. So the mitochondria of the father is not included in the zygote. The zygote contains mitochondria from the mother side, and this mitochondria from the mother side, which continues with us in our lifespan. So, mitochondria, in general, it is a powerhouse of the body. It's present in all eukaryotic cells. Let's have more close look for the structure of the mitochondria. As we see, the mitochondria is formed of two membranes, an outer membrane and an inner membrane, which folds on itself inside the space of the mitochondria, forming this crusty which we see it in the picture. And the main cause behind folding inside is to increase the surface area for the multiple operations needed to be done by the mitochondria. The presence of two membranes, we will understand it in the next slide, and while we understand the function of the mitochondria itself. But we understand now there is no cytoplasmic part inside the mitochondria, which means it will not be affected by the osmotic pressure, whether the mitochondria is in the cytoplasm or in hypotonic solution or hypertonic solution. So that the mitochondria is a solid structure formed of two membranes. The inner membrane folds on itself inside the mitochondria, forming what we see and which we call it cresti. And on this cresti, the different operations, the different function of the mitochondria is performed. What are the different functions, and why do we need this big surface area inside the mitochondria? In this table, you see a list of the different peptides which is working inside the mitochondria. These are the mitochondrial peptides. These peptides are specific to the mitochondria to help it perform its functions. Absence of one of these peptides will simply lead to one of the diseases. This is a very important part. We need to understand it very well. Different peptides, each peptide participate in a specific reaction to be done by the mitochondria, and reaction after reaction after reaction, making a circle. This circle will perform a certain function. It is not our subject, or as we promised, to make our lectures here more clinical, so that I will get away from the details of these steps and the different operations of the mitochondria. However, when we see here that we will find some of these peptides, when they are absent, will lead to inflammation, or when it is present, it will help in decreasing inflammation. When it is absent, it will lead to developmental disorders. When it is present, the development will be normal. Some of them help in differentiation of the fatty cells and the osteoclasts, and the different the other stem cells of the body. Some of them help in the process of apoptosis to fight cancer. Apoptosis is, we will have a separate lecture about the apoptosis, because it's a big story, and the Nobel Prize 2 years ago was dedicated to the scientist who discovered the enzymes related to the apoptosis. However, if these enzymes are not present and disturb the apoptotic process, this will enhance formation of cancer. Some of these peptides, if it's absent or increased or decreased, it will lead to metabolic disorders. Some of them will lead to muscle abnormalities. The very details of these operations, maybe it will not interest doctor from the clinical point of view. However, it is present, and I wrote the source of this picture, so that if you are interested to read more, you can take this source and read more about the detailed operations of the mitochondria. So, any of these peptides, when it is absent, a disease starts. Lots of the diseases we know is absence of one single peptide or more. Again, I come back to the insulin as an important example. One peptide deficient lead to the diabetes mellitus with its different types. This is the importance of the peptides, or what medicine call it, the essential peptides. I will go to one of the very important functions of the mitochondria to explain it in a bit details because it will have lots of clinical importance later on. As we see here, these are the two membranes of the mitochondria. In between them, there is something called the intermembrane space, or this is the channel of the protons, the hydrogen protons. Inside the matrix of the mitochondria, the NADH and NAD plus is transferred into NAD plus, releasing 2 electrons. FADH is dehydrogenated into FAD plus, releasing 4 electrons. And these electrons go in the intermembrane space. So the pressure gradient of the protons in the intermembrane space starts to increase, leading to influx in another channel to the electrons inside the matrix to be taken by the adenosine diphosphate, in addition to one of the inorganic phosphorus particles in the matrix, to phosphorylated and generate for us the ATP, which is the adenosine triphosphate. And this is the powerhouse of the cell. This is the main function of the mitochondria. As we see, when we read it, NADH dehydrogenase, succinate dehydrogenase, all these are the enzymes or peptides or elements or cofactors that help in this process, which we call it oxidative phosphorylation. NADH dehydrogenase, succinate dehydrogenase, cytochrome BC1, cytochrome C oxidase, adenosine triphosphate, adenosine diphosphate, and the phosphorylated enzymes. More than 20 enzymes participate in this process, leading to release of the ATP. As we see here, any imbalance in this oxidative phosphorylation, either by increase or decrease, either the hydrogen ions are more or less. If it is more, it will lead to degenerative diseases. If there is hyperfunction of the mitochondria, there will be degenerative diseases. This will promote cancer. This will hasten aging. This will lead to cell damage and subsequently cell death. Any delay or hypofunction of the mitochondria, which means there is deficiency of the hydrogen ions, will lead to insulin resistance, type 2 diabetes, and obesity. So the process should be adjusted 100%. Any increase or decrease, as we see, will lead to certain disease. All of this from one particle, which is the mitochondria. And as I promised you before, clinical importance of any organelle is the subject which we discuss here. So on the level of the muscles, we will have muscle weakness, cramping, reflux, vomiting, constipation, diarrhea, hypotonia, dysmotility. These muscles by its different types, either skeletal muscle or cardiac muscle or smooth muscles. On the level of the brain, the dysfunction of the oxidative phosphorylation will lead to developmental delays, dementia, migraine, autistic features, seizures, stroke, atypical cerebral palsy, and learning disabilities. On the level of eye, we can have vision loss, ptosis, optical atrophy, strabismus, ophthalmoplegia, retinitis pigmentosa. On the level of the ear, we can have hearing loss, heart defects, blockage, and cardiomyopathies, nerves, fainting, zero reflexes, heat and cold intolerance and pain, kidneys, renal tubal failure, liver, low blood glucose, liver failure, pancreas, diabetes, pancreatic failure, and parathyroid failure. Systemically, there will be a general weight gain, fatigue, short stature, unexplained vomiting, respiratory problems. So this is a disturbance of one of the functions of the mitochondria, which is oxidative phosphorylation, with its huge clinical implications. Due to deficiency of one peptide is quite enough. One peptide to disturb this process is quite enough to make for you all of these diseases and more. One peptide is enough, one essential peptide is enough. Deficiency or increase, however, increase does not have bad implications, as we have some stores to store the excess peptides. However, the deficiency will lead to devastating diseases as we see now. Thank you very much. As we promised, we try to make our videos as short as possible so that we do not waste a long time from you. Next lecture will be about mitochondria and apoptosis. We wish you all join us, and please do not forget to subscribe in our channel so that you receive any new videos as soon as it is published. Thank you.